Hi, this is Aaron Jerome, another video for Jerome Electronics YouTube channel. This is a really short one. This may actually be my shortest one ever. This is about binary addition. I know the title says binary addition and subtraction, but you need to know addition to be able to do subtraction. And so I just want to make sure everybody's on the same page for how to add in binary. Now, you've been adding since the second grade, and it's easier to add if you only have a 1 and a 0, but there are some things that you need to know about how a computer adds, and that's what we're going to be talking about here. So let's get into it. First of all, one of the coolest things that computers can do is math. I mean, ever since scratching a line in the sand with a stick or abacuses, those are ways to do math. And we made computers to save us having to do math. I often say I shouldn't be trusted without a calculator because doing math in my head is quite often wrong. So anyway, when we put a number into a computer, it's generally a decimal number, a base 10 number. And the computer, it has to decode that. We just finished making a decoder that works one direction from binary coded decimal to decimal, but it also works the other way. We can put a decimal number in. The computer has to decode that from a base 10 number into a base 2 number. So this is the number 12 in base 2. Computer knows what to do with this, but the computer always converts the number, and especially to do math. So these are red words. My students, you need to write these things down. This is kind of the things you need to memorize to be able to understand how computers do math. First of all, computers generally add a stack of 3 digits, not just 2. The stack of digits always results in but it's a 2-digit answer. On the right is always what we call the sum. It's kind of like the answer. But on the left is what we call the carry. This would be the carry over or the carry out. And so if we add a stack of 3 zeros, we get a sum of 0, 0. But what if we have 2 zeros and a 1? Well, that's a stack of 3 digits again, and the answer is 1, but we have to have a 2-digit answer. So the 1 is the sum, and the 0 is also the carryout. Okay? So it's also important to remember that it doesn't matter where the 1 is, and sometimes students think that matters, but it doesn't matter where in the stack the 1 is, the answer will be the same. All right, let's try for another stack here. This time we've got a 0 and 2 ones. Whenever this happens, well, this is actually 1 plus 1. In decimal, that would be a 2, but the answer has to be a 2 in binary. And if you remember when we were counting in binary or any number system and learning the laws, basically, when we maximized a digit, we had to reset that digit to 0 and increment the next left column. And that's what we're really doing here to make the number 2. This is a binary number 2, 1, 0. And again, the sum of this number is a 0, and the 1 is the carryover. And remember, also, it doesn't matter where in this stack of numbers the 0 is, the answer will be the same. Seems kind of basic, seems like we should know that already, but some students are a little confused by that. The reason I say that is because really all you have to do is remember a stack of 3 zeros, a stack of 2 zeros and a 1, a stack of 2 ones and a 0, and this next one, a stack of 3 ones. 1 plus 1 is 3. But we have to express that in binary with 2 digits, and so a 3 is a 1, 1, or in other words, a 2 plus 1. So the sum is a 1, and the carryover is also a 1. So if you understand how these stacks work, and really you just need to memorize these 3, or at least be able to derive the 3, you can add in binary. And so here's a sample binary number, and my suggestion is that you pause the video and see if you can add this number, remembering that even though it's not shown, there will be carryovers for each of these. All right, pause the video for a second, see if you can answer this, turn the video back on when you think you've got the answer, and I'll show it to you. So here's what we did. We said, well, 0 plus 0, it has to be a 2-digit answer. The right is the sum, and the left is the carryover, right? So it goes up here. So now we have another column, a 0, 1, and a 0. So 0 plus 1 plus 0, well, that's just 1, but it has to be 2 digits, 0, 1, with the 1 on the right being the sum and the 1 on the left being the carryover, and that goes to the next column. Okay, so 0 plus 1 now, well, that's a 2, but we have to express it in binary. 0 plus 1 is a binary 2, which is a 1, 0, and the number on the right is the sum, and the one on the left is the carryover. It goes to the next column. So now we have 3 ones, 1 plus 1 plus 1. That's 3 in decimal, but that is a 1, 1, 2 plus 1, in binary. So 1 plus 1 plus 1 is binary 3, which is a 1, 1. The 1 is the sum, and there's also a 1 for the carryover. Now, there's nothing below that carryover, but we have to assume that they are zeros, otherwise they'd be 1s. So that 1 plus 0 is equal to 1, but has to be a 2-digit number, 1 for the sum and 1 for the carryover. Now, before I move on, the carryover will be a 0 with 2 zeros under it. We know that those will be leading zeros from then on, and we won't be doing anything with those, so we know we're done with that. Okay, here is a problem that you should try solving. For my students, I'm about to give a test on this. Once you understand how to add, I'm going to give you a test. It's about a 10-minute test with 15 simple addition problems. Use scratch paper. You can't use your logbook. You cannot use a calculator. Just use scratch paper to add these numbers. These 3 problems that I'm about to give you are your practice problems. Pause the video. Give it a try. Okay, for this one, hopefully you got this answer. This is the correct answer when you add these 2 binary numbers together. That is 100011 plus 111011 equals 1011110. I don't know. Maybe somebody's listening and not watching and wants to hear it. All right, let's try another problem. Try this one. This is 10111101 plus 0111011. Add these 2 together. Pause the video if you need more time. Okay, here's the answer. 100110011. Okay, let's try a third one. Here's problem number 3. 111011 plus 101111. Pause the video if you need more time. Okay, the answer is 11001010. All right, so with this done, if you understand this, and if you're my student, ask me for the computer test for this. And if you feel you're ready. Otherwise, you'll just learn how to do it. You'll just have more practice. Okay, so next, the reason that we focused on addition is for the following reason. In a computer, addition is addition, but addition really fast, and of course a computer can do a billion tasks per second. Addition really fast is called multiplication. We're going to learn next about subtraction. And subtraction really is just more addition with a couple of tricks that we do. And then, of course, subtracting really fast is known as division. So With this last puzzle piece in place for subtraction, which I'll make another video about that next, but with that subtraction piece in place, you will understand how a computer can add, subtract, multiply, and divide. Soon after, we're going to make a simple little calculator. We'll get to that a little bit later on. Okay, that's it. Thanks for watching. That's what we need to know about binary addition. Talk to you next time.